We're logged in under my username. We're going to go and create a new project. This project is going to be called Demo Video. And here we are. This is the interface that users see when they first log in to the application. If they haven't logged into the application before, there's callouts like a walking tour that kind of hover and showcase what these various sections are for. What we're going to want to do in the very near term is figure out what type of graphics and copy we want to place in those areas. That way the experience is as intuitive as possible. The user will be able to navigate to these help centers that will function as get started guides. Another thought soon is to allow one of these to be load a sample project, which a user would be able to click and essentially pre-populate their environment, their project environment, with a active project, so that they wouldn't have to go and get screens or figure out how some of the things in the application work. Users begin by clicking the plus sign. We'll be bringing back the Sketch plugin soon, perhaps within the next 30 days or so. We now have a new version that's working, and it's really incredible. Users will be able to import directly from Sketch. Here is the general import screen. The tips are very clear. It's important that the images are 750 by 1334 in dimensions. When the images become larger than that or wider than that, we see a decrease in overall performance in detections and accuracy. So we really strive that users give us high quality images that come from design tools. Also, images that are high resolution in the sense of color, amount of colors, become like colored backgrounds, heavily colored backgrounds, also become a challenge if they're not designed correctly. So if they do it and the contrast is difficult to read even for a human, it's also difficult to read even for a machine. So the user can go ahead and select an image. So I'm just going to select an image from this testing UI kit that we've created. The kit goes through the process. It first extracts colors, client side extracts, it begins to look at UI elements, it looks for text. It also extracts fonts. When this process is complete, not only are there tasks that are created in the project, but there are prompts that appear from the side. These prompts allow the user to either accept or acknowledge functionality that's presented. All right, so I'm going to go ahead and add some more screens. So as always, there's a GitHub repository created. By default, that repository is a public repository that we host. In the future, when we go into the market, we'll activate all of the flow. We've removed some of that flow for now to make it a more streamlined process for users. That flow allows users to add their GitHub through our app store environment. An important thing is that users should note to improve the output or to get to completion on a project. They must make sure they complete all of their tasks and contribute the dependent tasks to the code base. Otherwise, blocking tasks will stop the code engine from continuing. Right? The code engine executes based on the tasks that appear in the tasks that were created for the project. If there are 0 tasks, then there will be 0 code created. If there are hundreds of tasks, then dependent on what those tasks are and if those tasks have been assigned to Annie, then Annie will be able to complete those tasks. It's very important to acknowledge that. Currently in this project, there's 31 tasks, 0 risks, 0 tasks that are blocking. There are 0 estimated team hours left. Team hours are the hours it takes for the team to complete their assigned tasks. And then last but not least, per Dennis's and Tomer's suggestion, we have the savings, the hour savings. It shows how many hours have been saved in the given moment based on what tasks have been completed by Annie. And then it shows how many more tasks Annie has remaining. So when this project is all said and done, there will be 68 hours, sorry, it just changed on me, 68 hours of tasks that the bot will complete for this project, which we can see here. It's completed 1. You can see how these things get calculated. As always, the tasks are classified. First, the tasks are mapped into a classifier that determines if that task is a developer task, a designer task, or a manager task. If there is a task where there is not a team member, then the task will remain unassigned and it will be flagged as a risk. If there are more than one of these, it will create a blocking instance. In order to overcome that, navigate to the settings view. And in the settings view, if you're the admin of the project, let's go ahead and add that. Let me just close some of these out. Yeah, we know that that's here. Yep. You'll scroll down to where you have team. You'll click on invite members and you'll give the team member their name. You'll give the team member their email address. That's where the invite will be shipped to, that they have to click to be accepted to the project. And you'll set their role. Today, the roles are 1-to-1. You have one person that can be one role. In the future, we have the possibility to explore a single person that might wear many hats in an organization. But for today, if I'm Ryan, I'm the manager, that's it. So, or if I'm Tomer, I'm the manager. If I'm Kyle, I'm the designer. If I'm Megumi, I'm the developer, wherever that needs to be, right? If that person's an admin, you can set it here. You can also give that person a specific title. Ideally, we can use these titles to discover over time as we get more users, new types of roles, and add that into our workflow. But today, 3 roles. You add somebody, it sends the invite out to that person, and when that invite's sent out, it will recalibrate this planner, this schedule, which it's always doing, by the way. Every single task that gets completed, every so many seconds that the task runner runs, every new screen that you add, whatever you do, code that you commit, code that's linted, all of that is constantly refactored and remapped. So you can go from, almost done today, do some things to the system, and then go down to 10% complete simply by increasing or adjusting the scope. So back into the story map view. I'm just going to keep adding a few more screens. Let's get like a login or something in here, and then a welcome screen. Let's get one that's more difficult and unique. Create account's cool. Go password. It's unique. All right, so while this continues, we acknowledge that we needed a, help me here, we needed a user object. So if we navigate to our data view, we can see that model. We can adjust that model. If there are other models that the system suggests for us, we can view those models as they appear here. Now this is an irrelevant one for us, so we're not going to use this one. Better model comes in, we'll go ahead and pull that model into our, hold on, it's loading, pull that into our flow. All right, so we have this reset password, we have this. We can take this composite view because, well, first, two things. Say we don't believe that this is a composite view. Let's say we believe it's a different type of view. We can click the view and we can change the view type. So we're going to go ahead and click that view. And we're seeing here that this composite view, possibly composite view, is a view of mixed UI elements. The composite view has an image located at the very top in the center of the view. And this is a placeholder image that needs replaced. And there's a composite view located at the top center with the text that seems that it's confused about. Either way, there are two image placements, no text placements in the view, and that's the makeup of the view. So we can click and actually see what those detections look like. We can see that there's these detections here, and we can see that these detections here. Now it's a multi-layer process, so never one screen has everything detected. There's like 7 or 8 different composite screens that are generated, some where we lighten, some where we darken. When everything is said and done, we merge everything together. We normalize it, so things that are nested or overlapping, we kind of deduce that to be related, and then that's how we produce our final output. To make it easier, we've set the output first to be the speaking navigation. So if I navigate over to the documentation, I can see in my requirements the speaking navigation. So this is what these specific screens are supposed to have in them, and what these specific screens are supposed to do in the project. So now let's go ahead and navigate to the code. So the code for some, or for many, is perhaps one of the most compelling outputs of the system. What happens is when we see things in the view, we're able to say, there's call it a login action, because there's a login functionality. We need to map that operation in that view to that action. So does that action do a network request? Does that action just trigger a segue to another view? Right? So all these tasks, including writing test, all when executed by the machine, are shipped over into a GitHub repository live. So last 10 minutes, you can see these files pushed over. There are basic config files. These config files they very rarely differ from project to project. It's when you get into more complicated cases, complicated scope, that starts to really change. So first, we can see that there's tests. So the first test is our global tests. These tests are the tests that are pretty much standard tests for making sure the app just doesn't plain out crash, making sure the app can actually connect to a network. And as the process continues, we'll create more of these tasks. More of these tests by way of those tasks. Here are some other tests that get created. So, like, let's say the welcome test. So for each story that's generated by analyzing what's in the view, the image captioning, we validate that is actually happening in the view. This is a test first code approach. This is one of the most practical and long tail effective approaches. You have model first, you have test first, and then you just have hacker. Hacking is bad. So with these tests, we have what the test is. It's commented out, and then there is a sample instance of the test that the user can either uncomment and use, or they can add on and create as extensive of a test as they'd like, need, or require. The system is tracking it all, including the GitHub commits that the user would ultimately make to contribute to the project. The AI does not write all the code. That is important to understand. All right. So, okay. So then there's other tests you can navigate as I'll share this repository. Next, we have two folders. One folder represents the client, whether that client's iOS, whether that client is React, whether that client is Kotlin, whether that client's HTML. The user would be able to see it directly in here. So then we have the server, and that's pretty self-explanatory. So most notably in the server is there are more or less routes and models. Now, some of the server code is still yet to propagate over. In our models, whatever models we accept, we see here. So here we have a base model. It's a a user model, these are the properties for it. If we adjust the properties in the admin in our product, we'll see those properties adjust here. If we accept other recommendations for other models, we'll see these models adjust here. They use standard Mongoose schemas or whatever ORM is required. If we change our database to Postgres, the Mongoose changes to SQLize, etc. So then we're going to navigate over into our view code. So again, we're still spitting new code. New code is still propagating over. We have our abstracted React application. Much of it is standard structure that just ensures it's easy for a developer to easily find information and tap into that information. First foremost, we're going to hit up our components view because our component views represent what's in the views of the screens that are uploaded. So we're going to start with this reset password view. So here are the requirements for this reset password view that came in by way of the image captioning, as I referenced earlier. Here's the requirements. React Redux, these are standards. The React strap and these imports are specific to the components that are in the view. So when the view has things like pagers and more complex UI elements, which we'll explore in another session, you'll see those things be imported directly from React strap, or in some cases, other libraries are added that have better approaches to that. We actually search the NPM library, and it's like a really cool process for how that comes together. So we have our actions that get imported by way of what's in the view. We have our state properties that get that are set up when your that were detected in the view. We have our core functions. The core function in this case, because it deals with networking, it creates a data object. It assigns that global var, the state var, to that object. It takes that object and passes that object into the Redux action that gets dispatched to the remote server's endpoint that can handle this network activity. So this is a lot of things that are happening simply by way of getting a glimpse as to what's on a screen. It goes ahead and updates the state, shows a loading indicator. We also, this case shows a handle change event. So anything bound to that event will just update the state value of that event, which is really cool. It's dynamic, so it's based on the incoming value. So if the incoming value target element's name is blah, then it will set state blah as the target's value, right? So foo, bar, whatever your case is. Here's a component mount. There's nothing that's being mounted. There are cases where it does mount data. It mounts data dependent on there being a binding requirement. Login doesn't have a binding requirement. We map in the state value for showing the loading indicator. We map in the data value for the props, and then when we return the code. So here we see the code composite. So if in fact this data props, so this .props.data has an error message, which means the error came from Redux, then it will, and the showed loading indicator is true, then it's going to show a loading indicator. Else, it's going to show this form. So this form is going to be, wrapped in a container. It's going to be an input group wrapped in an input. It's going to be classed so that the aesthetic matches everything else. There's going to be a value set for it. Here, this value is the global state value for email address. It's going to handle the on change event. So if I type A, it's going to put an A in the screen, and the A is going to actually stay there. Without that, it won't actually take on the inputs. That's what's amazing about Redux or React. The value of this element, when we pass it up to our form, it's going to be called email address. The placeholder text for this is called email address. And then there's a button. This button on clicks based on the term that was detected in the view. Now, there's a to-do for it, one for test and one for updating the copy that gets pushed over. So the user can come in here, map that value, map and bind the actions to the view, and their goal. They can come in here, make a few adjustments, and they've saved a tremendous amount of time, A, dealing with architecture, and B, dealing with the nuances of setting up files like this. All right, so again, we're just going to let this system continue to go, and we're going to while it continues to go, we're going to navigate back into our view. So let's see here. Tasks are burning away. We see here, we're up 13 hours in savings, which is tremendous. When it comes to like quantifying that, if I were a business person, I would say, I have 13 hours and I charge $500 an hour. I saved $6,500 just in the last 15 or so minutes that I have, 20 minutes or so that I have been on this system. So this will continue to burn down. Now let's get to the meat. The meat is, there's tasks that aren't assigned, there's tasks that need to be done, there's tasks that I need to do. For me to participate in that, I have to actually go into the README and follow the instructions. It's my job to go and fork the repository, just like I would if I were a developer working on anything. And then once I fork that repository, I need to check out my own branch. It's imperative that I check out my own branch. Then I need to make changes to the code and commit my changes. And when I commit my changes, that code will be linted. When that code is linted, it will provide and debugged, it will provide a list of errors or a list of whatever needs to happen. So as a user, I'm going to go ahead and actually navigate back to this repository, and I'm just going to make it easy and do the desktop clone. So I'm going to open this in my desktop. Boom. So now I'm cloning the code, and I'm just going to keep it easy and make one small change to the code. Alrighty. Excuse me. Oh yeah, that's Ryan's workspace. Don't know how crazy. Demo video. So here's the new workspace. So I'm a dev. I'm gonna come in here. I don't like the way this is, so I'm gonna come in this, and I'm not gonna bother branching. This forgot a comma. Actually, I'm going to take the comma out. I'm going to add 2 commas here, just so I can reference it later. I'm going to say that's what I want to change. I'm going to go ahead and commit it. And it's committed. We got the ping right here in Slack. You heard it. There it is. Boom. There it is. And we could also see it here. There it is, my first commit. And then we're going to go back to our view and let it rip. Let's see. All right. Go Speed Racer, go. There we go. Oh, yes, yes, yes. Okay. So what do we have here? So we'll leave this open so you kind of see this thing simultaneously go. Remember, there's 31 tasks. There's currently 3 risks in the project, 0 things blocking anything. 69 hours left for teamwork, human work, and 13 out of the 55 remaining tasks, hours of value created by the machine that will be complete. So we found a bug in our composite tests that needs to be added. We found several. Looks like a bunch of clients. So all these bugs right here that were found in the code base, it looks like a bunch of comments, found in the code base by way of either my edit or an edit that was created or something that wasn't dressed properly or formatted properly. All of these bugs get added to the user's project plan. Let me see if I get a bit of hard refresh. There we go. So they're adding in still. So we're now up to 33. Here we go. There's 2 bugs right there, notably here. If Annie can complete the bugs, they'll be completed. If she can't, she won't. We know the specific line. We know what the specific bug is. We can go ahead and fix it. So we'll see things like that factor in the project as the project continues to go under development. Let's see here. Another important thing is our design system. So when we look at these elements, what we're doing is we're extracting the elements so that we can create a universal style guide. That way, the style guide is where the styles are referenced from and not kind of inline hokey with height X, Y on element renders. So by default, we're going to populate the environment with our standard UI kit. That way somebody, even if they don't have screens, has a baseline to work from. There's a note there, so we just make sure we get it done. Here's a lavender button that was detected by way of looking at one of the views. Its font, its color, all those things all come from that element. Next we have, where's that, textiles? The textiles. So these are the specific fonts that were pulled, extracted from that element. So in our code base, this is what gets referenced. We now use Arial font in our code, etc. So it's just important to acknowledge how that plays an important role in making sure that when you make the view, it looks like the view that you make. And going forward, as you add other views, there's continuity in between those views, so it feels like it's one application, even if you go Frankenstein and add multiple screens. Let's see here. Next, we have our intelligence view. So our intelligence view it's currently rocking, so we're waiting for it to propagate. It's going to give us our details on health and burn. While that runs and just computes, let's just take a look at this guy for a second. In a walkthrough that I was doing earlier with our team, I found that, let me plug my machine in. I found that there is something important to point out. There we go. Something important to point out. How these tasks are assigned. So initially, the tasks are assigned based on role class. If I'm a developer, I'll get developer tasks. If there are 6 developer tasks and I'm a developer and Dennis is a developer, he'll get 3 tasks, I'll get 3 tasks. If I complete my tasks, I'll get assigned one of his tasks until all the tasks are burned down. That's the goal, to move as quickly as possible. Now, there are things that happen where, let's say, Dennis is... Yes, please. Sorry about that. There are cases where... I lost my train of thought. There are cases where users can... User commit and tasks are measured and monitored. So our intelligence now views it in this way. So we can see, how many commits were made. We can see where technical debt arises on a project. So we can know specific files where so much code is being reworked to the point that this is non-efficient, right? The code was never good, or the person working on that technique was not necessarily the best for that job. We're able to see, the macro, how much work is new work versus, which indicates growth and innovation, how much work is modified work, which indicates people not necessarily know what they're doing or needing help with something, and work that gets removed. This work that gets removed is work that is essentially bad work. It's bad code that should have never existed, all associated with technical debt. All of this data is what we use to figure out how to continue with task assignments going forward. What you'll see soon is in our UI, more of this data present itself, so that as a manager, I can come into here, see where the progress is on my team, on my project, understand where there's risks, and optimize so that we can deliver this software faster, and we can deliver this software in an efficient way that saves us time, therefore money. Users can also view the files directly in the view. This is synchronized with GitHub. So I can come in here and I can say, I don't know, show me a composite view, and I can see, there we go. I can see the composite view, again, the requirements. I can see, the imports. I can see any actions it mapped in. I can see any pieces for state. I can see, here's an image. I can see all that information directly in here. Another case is if I, let's say, upload, let's do this. Let's upload, let's try to break our project here, right? So let's go in and upload a login screen. So this screen is going to process, do its thing. We're waiting for the screen to process. While we wait, just look at some of this stuff. We can see how the detections work. Whenever you see cardstock, that means the icon classifier is the one that will get it. We actually independently look at text, independently look at UI elements, and independently look at icons, just because it improves our accuracy for those types when they're clustered together or grouped together. Here's a case where this is another layer which looks for specific texts, both nested and unnested. So like, the light green indicates it's an unnested text. That's why these ones stand out. So that's why it's able to capture that. It's really cool. These, another important note, you won't typically see these. They're for us to validate and test and make sure we're capturing all the information the right way. So alrighty, loading away. All right, so we're going to do that 2 more times. What our goal is to add a login screen several times, because what it does is creates a big error actually in our runner. So just allow it to a moment. What will happen is we'll be notified that we're creating blocking cases and risk. So again, if you guys are going to test a variety of images that have different concepts, or manually override the concepts, because when the detections start to overlap, it will overlap the output files. It will create a mess, because a view shouldn't have 5 sign-in screens. A view shouldn't have 5 home screens. It might have a home screen that has various states, but not 5 screens designated to be a home screen, right? It becomes anti-pattern to the abstraction, it becomes anti-pattern to the file system, and it definitely becomes anti-pattern to how the system works in general. So we're just going to let that roll and give us some data. Another thing is, users have multiple places to respond to if they've completed a task. Now, they get a task request directly inside of Slack when they connect Slack. And if they don't connect Slack for whatever reason, their organization doesn't use it or they use some other tool right now, the user can come in and you can see we have a blocking task now. The user can come in and say, this particular task I want to assign to somebody else, or better yet, this particular task I want to give an update on. I want to say that I'm done or I'm not done or whatever it is. They can type that in, give it a status update, and even change the next time the bot will follow up to check in on where they live with that task. Again, I just want to specifically show the blocking task. There it goes, boom. So here, the project needs rethinking as the scope coming from the sign-in is repeated 2 times, or repeated in 2 views. It's becoming redundant, anti-pattern. This is high risk and needs addressed in for the project to proceed. So this becomes a major to-do that needs to be managed by a user, which you can see here. Something else, though, you can see is that, again, we can read this text, and we can see how this text matches what's in this view. We could also see the raw detections just to confirm that, this is, it's pretty cool technology. We can see it's a form. There's these variables. There's these actions that are added to the view. So if we open up our code editor, we have a blocking task that might not. Oh, it's in. No, did it make it yet? No, it didn't make it. So we have to wait for the block. We have to complete the blocking task. That way we can see that that data populate in. Let me see here. Let me just try one more time. Just now, there we go. Did we get it yet? Oh, there we go. It pushed. Okay, so here we have our information. Here's our details that were detected by way of the view. We have our login actions coming in from our sign-in action. Again, we have our props. We have our indicators, our password or email. We have a login event passing to that action. Again, we're creating a login data set. We're passing password from state, email from state. We're doing a dispatch. We're showing the indicator. We're handling the change. There's no mounting data. We're dealing with that. We're dealing with the right var assignments. We have our loading indicator. Here we have our import group for our details. Here's our done button if we wanted to keep it or not. It was detected in the view. Here's our sign in button if we wanted to use it or not. And everything's here to make your view come true, right? So really, really, really cool. And this is just one of the component files. There's other files that handle network and data and things like that, which are just as important in the view. Again, these are bugs that haven't been addressed yet, so we'll continue to get notified on them, which is good and bad. We might even just call out the total amount of bugs that were detected, so it's just one card, because I can see how this could be inundating. That's an easy modification. Has less to do with does it work or not, more to do with is it easy to use or not. Again, our requirements begin to become more verbose. We're still waiting for some server-side dependencies to populate in. Again, you can see where conflict's starting to arise, where there's redundancy and things like that. Yeah, it's good stuff. It's good stuff. So I'm going to check on project intelligence one more time. Oh, it's burning down more. All right, we see the risk. There's tasks that does not have someone on the team to complete. The repeated scope and sign-in is coming up twice. So we're starting to see some risk. Over time, it will show the risks on a spark line so that users can see that. As it continues to burn, we'll start to see it continue to optimize down. For it to burn all the way down to 0, though, you'll have to have a full team. That way, the predictions can all be made. Otherwise, the predictions are partial because it only has a partial glimpse into what resources you have that can get this thing done. So, yeah. Good stuff. Good stuff.